In the last video on domain and range, I looked at domain and range in terms of a graph. So looking at the possible x values, possible y values across a visual representation of the function. What I'm going to focus on for this video is how to find domain when you are just given a function, just given an equation. So the first thing you need to look for when you want to find the domain is you need to look for square roots. All right. Square roots, basically, we want our domain to have only real numbers. And with square roots, it's entirely possible that you would get imaginary answers which would not be included in your domain. And so that's why we want to look for square roots. Those square roots can be in the numerator or the denominator. And if we're talking numerator or denominator, you probably need to be concerned about fractions. Okay. So we've got fractions, definitely those square roots. All right. Order on these we'll talk about. But I'm just basically filling it in. And anything factorable in the denominator, because it's a fraction, so we want to pay attention to that denominator. Your denominator cannot be 0. Okay, you are not allowed, nobody is allowed, okay? It's just, you're not allowed in math to divide by 0 and try and get an actual number answer. So we consider that undefined, and because it's undefined, we want to not include that in the domain. Okay. It's also helpful when you are looking at interval notation to possibly draw what is possible versus what's not possible for your actual domain. I'm going to look at a few of these examples for this one and possibly pop up a secondary video to go through the other ones. First problem I want to look at is just number 4. We're supposed to find the domain. I don't have any square roots, but I do have a fraction. And so I want to focus my attention on the denominator of that fraction. And we know, mathematically, we can't allow that denominator to equal 0. So you could say x minus 3 cannot equal 0. Looks a little strange, but that's true. And either mentally solve it, or you can actually subtract 3 from both sides, and you would be able to, or I'm sorry, add 3 to both sides, and you'd be able to tell me that x cannot equal 3. All right, if we put 3 in this denominator, 3 minus 3 is 0, and 4 divided by 0 does not work out so well when you are trying to solve a problem. So what's the actual domain? Well, if I think about a number line, okay, and here's the number 3. Everything larger than 3, totally fine. Every number smaller than 3, totally fine. What's not fine is the number 3 itself. So this interval starts at negative infinity, it goes to positive 3, and then it unions with 3 to infinity. So interval notation, infinities always take parentheses, whether it's negative or positive infinity. And because we can't actually use the value of 3, the 3 also takes parentheses. So the interval that represents the domain for example 4 is those intervals. All right, it's a compound interval, or I think it's a joined interval. I forget how to phrase it. But basically make sure it has the union to join the two pieces together. All right, so that's example 4. If I take a look at example 5 here, okay, my focus is square roots and the denominator. So I have, oh look, a square root in the denominator. So a couple of things here. Square root, I want to make sure that what's underneath the square root becomes a real answer. No imaginary numbers. So when I do that, I'm going to take the expression under the radical and do one of two things to it. Either I am going to set it greater than 0. That means it would only be positive solutions. Or I'm going to set it greater than or equal to 0. And so if, let's say I just say, okay, it's going to be greater than or equal to 0. But this square root was in the denominator. So while the square root is totally fine to be greater than 0 or equal to 0, the denominator cannot be equal to 0. So that little equal to part I am going to delete because the square root is in the denominator. So I always start with putting the greater than or equal to part and then logicking through, can I actually have a value of 0 if it's in the denominator? The answer is no. So x plus 1 is greater than 0. I'm going to subtract 1 from both sides. So x is greater than negative 1. Okay? So that takes care of my denominator. That takes care of the square root. It doesn't matter what x in the numerator is. It's not a square root. The numerator of a fraction can be any value it wants to be. So don't worry about the numerator in this problem. All right? It's fine. So number line-wise, if you have a negative 1, I don't know why I just wrote a 3. Let's try negative 1. So x is greater than negative 1. So that means I want to pick everything larger than negative 1, but I can't pick negative 1 itself. So my interval is going to be from negative 1 to infinity, parentheses on both of those. All right, the last example I'm going to do for this video, and then I'll go ahead and pop up a second video going through the rest of the problems. I'll go ahead and talk about problem number 6 here. Okay. So problem number 6, example 6 here, no square roots. That's nice. However, we have a denominator here. And so this denominator, I cannot allow it to be equal to 0. It's x squared plus 3x minus 10. I'm kind of thinking it's factorable. Okay. So I'm going to take a second. I'm going to factor it. And I'm going to say that this is x plus 5x minus 2. That should work, right? Yeah, it does. Okay. And I can't let either of those factors equal 0. Because if either of those factors is equal to 0, then the whole denominator is equal to 0, and I can't divide by 0. So if you wanted to, you could either mentally solve this or just take the two factors and say that they can't equal 0. So x cannot equal negative 5, and x cannot equal 2. All right, if you solve those two little equations. And so on a number line, right, everything is good, right up until we hit negative 5. Then I have to throw that number out. And then from negative 5, everything is great until I hit 2, and I have to throw that number out. So interval-wise, we're going to go from negative infinity to negative 5, union with negative 5 to 2, and then 2 to infinity. So this set of 3 intervals, where they're all unioned together, is the domain of problem number 6 written in interval notation. Again, why did I not even pay any bit of attention to the numerator? Because the numerator can be anything. It can be 7, it could be 12, it could be negative 300. I don't care. It could be anything it wants to be, including the number 0. So all I have to focus on is the denominator part. All right, so I'm going to go ahead and close this one out. If you want to take a look, I'm sure I will pop up the secondary video for questions. I think it was like 7 through 10. I will, or example 7 through 10. I will get to those in a second video. I hope this helps explain a little bit about how you find domain given a function.